Good morning, everyone. Sorry I couldn't be there today. So what we're going to do is we're going to finish the notes that we started on Tuesday. So we are on lesson 4. I believe with second period I was able to get through example 5, but with third I did not. So we're going to pick up right where it says lesson 4B, exponential function manipulation. So let's look at that example number 5. It says to graph f of x equals 2 to the negative x on the grid to the right, and then use the graph to obtain g of x equals 2 to the negative 2x. So let's fill out the table first, and then we'll graph. So for f of x, and I'm going to do this one in black, so I'm just going to highlight it gray. We're going to get negative 2 and plug it in where that x is at. But remember, I'm going to zoom in for a second. You're only replacing the x, so that negative is going to stay there. Okay, so when I fill this in, this would be 2 to the negative, and then we're going to replace x also with a negative 2. So that double negative makes it turn to 2 to the positive 2, which we know is 4. Okay, then let's just do that all the way down. So 2 to the negative negative 1, which is just 2 to the 1, which is just 2. 2 to the negative 0, which is 2 to the 0, which is 1. 2 to the negative 1, which is 1/2. And 2 to the negative 2, which is 1/4. So let's plot those points as accurate as we can. So we have the point negative 2 comma 4. So about right here. Then negative 1 comma 2. 0, 1. 1, 1/2. And then 2 is 1/4. And even though it's not on here, I do know that negative 3 would be 8. So I'm going to go ahead and plot that point. And then let's connect them. So just like that. That would be function f. I'm going to put an f next to it. Okay, but now let's try to graph g of x. So I'm going to do this one in pink. So this one has that additional 2 in the exponent. So when we are graphing these points, this would be 2 to the negative 2, and then we're only going to replace the x, and in this case, we're replacing it with a negative 2. Well, negative times a negative would be a positive, so this is 2 to the 4th power, which is 16. Okay, next one, 2 to the negative 2, plug in our x, so negative 1. This would be 2 to the 2, which we know is 4. 2 to the negative 2 times 0, which is 1. 2 to the negative 2 times 1, which is 2 to the negative 2, that's 1/4. And then 2 to the negative 2 times 2, that's 2 to the negative 4, which is 1/16. Okay, now let's graph these points. So starting with negative 2 comma 16, here's negative 2. 16 is going to be way off our graph. It'd be up here. Negative 1 comma 4, so negative 1, 4. Zero comma 1, so it's going to be right on top of that previous point. 1 comma 1/4, so lower than the block 1. And then 2 comma 1/16. That is so small that honestly I feel like we could just put it on top of the axis and that'll be fine. Okay, so let's connect those points. So this would look something like like that. Okay, and that is our function g. Okay, so then example 6 says, show that function g of x equals 2 to the negative 2x can be written in the form of h of x equals b to the k, and then that whole thing raised up to another power using the transformation properties in the table shown in the previous page. Describe the transformation from the parent function to each of these. Okay, so I'm going to try to keep my colors consistent. So g of x is in pink. They want us to rewrite it as this. H of x equals b to the k and then raised up to another power. So let's start by doing that. Okay, so if g of x is equal to 2 to the negative 2x. Okay, so what I'm looking at is in this exponent, it's like I have two values being multiplied together, right? Negative 2 times x. I'm going to scroll way to the very front of these notes. That is actually going to be the power property. Whenever you have two numbers multiplied, it's because one of them was the original power and then it got raised to another power. So we could just split those two things up. So I can write this as 2 I'm going to split it up a weird way, guys. So what I'm actually going to do is I think that we should do 2 times negative x. Like that's technically the power. So instead of keeping the negative with the 2, I'm going to make the negative be with the x. Okay, so then that means that this would be 2 to the 2. And then that raised up to the negative x. So this is going to be my final answer. This will be h. So let me switch my color. So h of x would be 4 to the negative x. Because I know that 2 squared is 4. So now it looks like that. Well, actually, this first one right here kind of looks like what they wanted. But we always simplify when we have numbers. So we have our two forms. But now they're saying, describe the transformation. So with g of x, I have I have a 2 right here. The parent function that they wanted us to compare to is 2 to the negative x. So the negative sign here, let's kind of like ignore it. From negative x to negative 2x, they put a 2 there. And back on our table of transformations, when we have numbers in the exponent, so just like right here, there's a 3, that's going to be a shrink or a stretch, depending on what number it is. We have a 2, so it is going to be a shrink. So g of x is a horizontal shrink of f of x by a factor of 1/2. So I know it's a 2, but remember it's always opposite. So if you look at the picture, let's go back to the graph that we actually did. So we're looking horizontally. So right now, f kind of starts at negative 3 and then it ends here. Well, if it gets horizontally shrunk, it's going to get skinnier. It's going to get squished in. So look at g compared to f. See how it's a lot skinnier? It's because it's getting squished in. And then if you even look at these points, like this was at negative 3, but now it's halfway and it's at negative 1.5. This was at negative 2, but it's getting shrunk halfway, so now it's at negative 1. Okay, but if you look at it in terms of h of x, well, here's negative x, here's negative x. That's the same. The thing that changed here is the 2. It's now a 4. So what that means is like it doesn't even have the same base anymore. So h of x is a change of base of f of x. So what that means, so this is exponential growth. It was growing by a factor of 2. Now it's growing by a factor of 4. So let's say growth factor doubled. So, and in parentheses, it was from 2 to 4. So I know it doesn't look like growth. It looks like decay when you look at the picture because it's reflected. The negative sign means reflected. But look at the black one. I mean, it's growing, of course. But then look at the pink one. It's growing a lot faster. So the growth rate doubled. Okay, so from what we did on Tuesday, we know that when we have a horizontal shift, so when you move left and right, that's the same thing as a vertical stretch or compression, depending on the number. Well, now from this example, we know that when we have a horizontal stretch or compress, that's the same thing as just changing the base. Okay, so even more transformations. What happens when we start shifting vertically? So this one has a +3 at the end. So example 7, use the grid at the right to graph f of x equals -2 to the x and g of x. Okay, so this time they didn't really give us much room to do a table, so we're going to have to wing it. But I promise this is easy. Let's see, where should I start? Okay, so it is a vertical reflection. So normally, I'm going to do these numbers over here because they are easier to work with. 0 times 2 is still 0. But then making it negative is not going to do anything. Okay, so then what if I plugged in a 0 here? Well, 2 to the 0 is 1, but then I have a negative. So this one is going to cross at -1. Then if I were to plug in a 1, 2 to the 1 is 2, but make it negative, so -2. If I were to plug in a 2, 2 to the 2 is 4, but make it negative. If I were to plug in a 3, 2 to the 3 is 8, but make it negative. It only goes up to 7, so I would guess that 8 is about right here. So now that I can see the pattern, the rest of it, I'm just going to kind of sketch it in. It's going to go really close to the x-axis. So I'm going to label this as F. Okay, now -2 to the x plus 3. Well, I know that whenever I have a +3 at the end, that's a vertical shift up. So the points that I have, let's just shift them up 3. So starting with this one, 1, 2, 3. And then this point, 1, 2, 3. This point, 1, 2, 3. And then I know at the 3 it was supposed to be at 8, but if we go 3 up, it'd be 7, 6, 5. So it's going to be at the -5. So this one is going to look more like this. And they're really close, so I'm going to put G right there next to it. Okay, so part A says to label the y-intercept for each function. So we can clearly see them. That's y-intercept of G. And this one down here is y-intercept of F. Let's also actually write it in here. So 0, -1, and then this one was at 2. Describe the transformations for each function compared to the parent function 2 to the x. So if the parent was 2 to the x and it changes to -2 to the x, f of x, so I'm just using the names, is a reflection over the x-axis. But this one here, comparing it to the parent function, it has that negative, so it's also a reflection, but it also shifts up. So G is a reflection over x-axis that has been shifted, or let's say translated, 3 units up. So one of the cool things about this one is asymptote is usually right on top of the x-axis. When you have a vertical shift, that actually tells you where your new asymptote is going to be. So the asymptote is now at 3. Okay, let's do number 8. It's kind of similar. It's a different function, but it's similar. They want us to graph. So let's start by graphing f of x equals 1/3 x. Because I know that this one's going to be exponential decay, I think it's going to be easier to plug in these negative numbers. So if I were to plug in a -3, that means that we would flip this over and then just do this. 3 to the 3rd power is 27, so way too big to graph. Okay, if I were to plug in a -2, that means I flip this over and make this positive. 3 squared is 9, so that's going to be right on the edge of the graph. 1/3 to the -1 is going to be 3. 1/3 to the 0 is 1. 1/3 to the 1 is 1/3. And after that, it gets pretty small, so it's hard to graph. So let's connect the points that we do have. And since I already can see ahead, there's my y-intercept. So y-intercept of f is at 0, 1. But now let's do G. So I actually know the transformations already. So I think we can fill out part B and then we can go backwards. So the transformations that I see is there's a -4 here. So G is shifted 4 right. And then this +2 and 2 up. So now that I know what's going to happen, let's actually graph this. So I'm going to take just these points that I already have. If I go 2 up and 4 to the right, would now be here at 4, 3. Same thing with this point. It was at -1, 3, but I'm going 4 to the right and 2 up. So right here. This 1/3 is kind of hard to do that with, but 4 to the right would be at 5, and then 2 up, so 2 1/3. Okay, so with those points, it would look like this. So this one is G, and this one was F. Okay, I think that's enough examples for today. What I'll do is I'm going to upload this video now, and I will do the rest of this stuff for tomorrow's video, and we'll have a short assignment tomorrow.